Hi guys, today we're going to be doing a trigonometry application, which means we're going to be applying our sine, cosine, and tangent ratios to some real-world problems. And those problems are going to involve the angle of elevation and depression. Okay, so let's take a look at this first one. Suppose an operator at the top of a lighthouse, so that would be like somebody up here, sights a sailboat on a line. So sailboat's down here. That makes a 2-degree angle with the horizontal line. So again, this is like our horizontal line going straight across, like the horizon, straight across, somebody looking straight out. If the person was up here looking down, there would be an angle in between, that discrepancy, right, of the straight across versus the down. Right there, that angle is called the angle of depression. Okay, that's somebody at the top looking down. At the same time, there's a person in the boat down here, and that person has to look up to the top of the lighthouse. So that person's angle with the ground looking up is going to be the angle of elevation. Okay, now here's the thing. That horizontal line of sight there and the ground there, those two are horizontal. Okay, which means since they're both horizontal, they're also parallel to each other. And since they're parallel to each other, those two angles right there, the angle of depression and the angle of elevation, those two angles right there are going to be alternate interior angles. And of course, we know that when we have two parallel lines cut by a transversal, our alternate interior angles there are going to be congruent. So the angle of elevation is congruent to the angle of depression. One other quick thing I just want to remind you is that when we talk about depression, we're talking about down, right? Something being down, it's depressed, it's down. Versus elevate is up. So the angle of elevation is looking up. So if you notice where these two are located, the angle of elevation is going to always be located inside at the bottom of a right triangle. And the angle of depression is always going to be outside of the right triangle at the top. Okay? Now, these problems are actually not that hard to solve. The trickiest part is actually setting up a picture to be able to figure it out in terms of what trigonometric ratio that you need to use. All right, so first piece of advice, always start with a right triangle. So start by creating a right triangle. Okay, now, talks about the sun's angle of elevation, right, is 38. As I mentioned up here, the angle of elevation is always inside at the bottom of your right triangle. So we're going to put that angle down there. It says a building casts a shadow. Now, of these three sides of my triangle, where would the building be? Well, it's not going to be laying down on the ground, and it's not going to be slanted. It's going to be this right here. That is going to be our building, the height there, how tall. It's going to be standing straight up. The building casts a shadow of 45 meters. Now let's talk about shadows. Where do you find shadows? Your shadow is always on the ground. So the shadow is actually this length right here. It's on the ground, 45 meters, which means our sun is somewhere over here casting its shadow. Now, the question is actually asking us to find how high the building is. That would be this length right here. How tall is the building? So we're going to call that x. And now what you see is you actually have a right triangle there. All right, and so from your 38-degree angle, you have an opposite. All right, so that's going to be our opposite. And we also have this side right here, which is going to be our adjacent. Now, if we remember our SOHCAHTOA, right, that will help us to figure out which ratio we should use. Now, we have an opposite and adjacent, so that means we have to use tangent. So the tangent of the angle is equal to the opposite over adjacent. So tangent of 38 is equal to the opposite from the 38, the opposite's x, over the adjacent of 45. Okay, so now we've got to put in our calculator tangent 38, and that's where we get that number right there to be 0.7318. Okay, and we're going to set up our proportion. We're going to cross multiply. And when we cross multiply, we end up with our x equaling 35.2 meters there, 35.2 meters. So we're going to round that off. That's approximately 35 meters high. Okay, that's how tall the building is, about 35 meters high. All right, let's take a look at the next one. Again, we're going to start with a right triangle. Always start with a right triangle. Okay, now it says from the top of a lighthouse. So we need a lighthouse in this picture. Again, lighthouse not laying on the ground, not slanted. So that means our lighthouse has to be out here. Okay, so I'm going to make this be my lighthouse out here. All right, and the top is here. Okay, so there's my lighthouse. and it's 20 meters high. All right, sight's a sailboat. Sailboat is down here, okay? Sight's a sailboat. Now, it says it has an angle of depression. The angle of depression is not inside the triangle. The angle of depression is actually going to be, I'm going to put this horizontal line across. The angle of depression is actually outside. Remember that. It's actually outside the triangle up there. But one thing we did say is that that line and that line are always parallel, so that means our angle of depression and our angle of elevation are always congruent. So whatever angle of measure I put there, I'm also going to be able to put it there. Angle of depressions and angle of elevations are always congruent. Now the question asks us, how far from the lighthouse is the boat? So that means we want this distance right here. How far from the lighthouse is the boat? So I'm going to put that as my x value. That's what I'm looking for. So we're going to focus on this right triangle right in here. That's what we're going to focus on. So from our 4-degree angle over here, we have an opposite. And once again, we have an adjacent, because we're looking for this side right here. All right, so opposite, adjacent. Once again, that's tangent. Tangent of the angles, opposite over the adjacent. So the tangent of 4 is equal to the opposite 20 over the adjacent of 4. Not 4, sorry, x. Adjacent is x. 4 is the angle. All right, so now we got to cross multiply. But before we do that, we got to get our tangent of 4. That number is 0.0699. We'll put that over 1. We create our proportion, and we cross multiply. And when we do that, we get that number, that x is on this side, and we have to divide, right? We're going to have to move that number to the other side over there. So essentially, we're going to be dividing by 0.0699 on both sides there. And when we do that, our x value works out to be 286.01 meters, which is about 286 meters there. Okay? All right, and the final question here down at the bottom, once again, we've got to start with our right triangle. Now, this one's going to be a little bit more difficult. And the reason I say that is because they threw another factor in here. A diagram of a person who is 1.5 meters tall, standing 20 meters away from the base of the building. So I'm going to draw this picture. Instead of having the person be like standing on the ground here, just to represent that person's height, okay, I need to represent their height here of 1.5 meters. Now, our building, again, the height is still out here. All right, so I'm just going to draw this one just a little bit differently so I can account for that 1.5. What I'm going to do is I'm going to create a rectangle down here at the bottom. And what that's going to do is that's going to account for our person of 1.5 meters there. So if that's 1.5, so is this, because we know that rectangles have opposite sides equal. Now it says the person is 20 meters from the base of the building. So their distance here from here to here is 20. Now I want to work with my right triangle, so we know rectangles have opposite sides equal, so I need the 20 to be up top there. It says the angle of elevation is 58. Again, we're focusing on our right triangle in here. You've got to keep in mind the right triangle that we're focusing on right here. The angle of elevation is inside there. It's actually this angle right here down at the bottom of that right triangle. We want to find out how tall is the whole building. How much is the height of this building here? Well, what can we do? If I find out what this length is right here, I could add that length to this length, and that would give me the height of the entire building. So I have enough information to do that. I have a little right triangle in there I can work with. From the 58-degree angle there, right, we have an opposite, and we have an adjacent. Oh, once again, another tangent. Guys, just keep in mind, we can use the angles of elevation and depression can be used for any of our trigonometric ratios, sine, cosine, or tangent. It just so happens that these three problems were all tangent. So the tangent of the angles, opposite over the adjacent. The tangent of 58 is equal to our opposite x over our adjacent of 20. And we need to get that tangent of 58. That's 1.6003. over 1, right? Setting up our proportion here, and we're going to cross multiply there. And when we cross multiply that, we end up with x equaling 32. Now this one in the calculator actually works out to be 32.000, so it's already there about 32 meters. But that's only our x value. That's just this part from here to here. That part is the 32, right? We have to add the 32 plus the 1.5 to get that entire height. And we find out that that entire height of that building is 33.5 meters is the height of that whole building there. Okay, now, a couple things to remember when we're doing this, working with angle of elevation, depression, we're doing this kind of lesson. First of all, remember, in each of these, you have to create a right triangle first. The second thing you have to remember is that your angle of elevation is always at the bottom, inside of your triangle, and your angle of depression is always at the top, outside of the right triangle. The other thing we need to remember is that our angles of depression and elevation are always congruent. Okay, they're always congruent, so don't let yourself be confused there. Okay, guys, if you didn't understand any part of this lesson, go back and watch the examples again. Good luck.